Yeah, very good morning. Shall we begin the session? Yeah, today's topic is processes. That is, what are the exceptions that is used? Yes, exceptions are basic building block of a system that is done by the processes, or processes are the program in the execution that are the most common or the most profound process that is available over here. So processes are the basic building blocks that offer allows operating system to provide a notion of a process, one of the most profound and the successful ideas in the computer science. When we run a program on the modern systems, we are presented with the illusion that a program is currently being running in the system. One of the methods that appears to have exclusive use of the processors in the system. And our program appears to have exclusive use of both the processor and the memory. Alright, okay Joseph. Okay, wait. So exceptions are the basic building blocks that allows operating system to provide the notion of a process, one of the most profound and successful ideas in the computer sciences. And when we run a program on a modern system, we are presented with the illusion, we are come with the illusion that our program is the only one currently running in the system. And our program also appears to have exclusive use of both the processor and the memory. And the processor appears to execute the instruction in our program, whatever the program we are taking out, one after the another without the interruption. And finally, the code and the data of our program appears to be the only object in the system memory, and these illusions are provided to us by the notion of the process, whatever the notion that we are considering, that is illusion is done with the various processes that provide successful ideas in the computer science. And the classic definition of a process is an instance of a program in execution, whatever the instance that we are giving, whatever the example we are giving for the program. And each program in the system runs in the context of some processes, whatever the process we are considering, whatever the data we are considering, that provides a context that consists of the states that the program needs to run correctly, and the states includes the program's code and data stored in the memory, its stack, and the content of a general purpose register as its program counter, environment variable, and the set of the open file descriptors. Each time a user runs a program, the name of the executable file to the shell creates a new process and then runs the executable object file in the context of the new process. That includes a logical control flow, that includes a private address space, that provides the illusion that our program has exclusive use of the memory system, whatever memory system we are using, whatever the data we are using. Now, what is the process that provides each program with the illusion that it has the exclusive use of the processor? Even though many other programs are typically also running concurrently, that means more than one process are running concurrently at the same time. And if we are or were to use a debugger to a single step, then the execution of the program we would observe an PC, that is a program counter that automatically update, that automatically relieves values that correspond to the instructions contained in our program executable object file or the shared file that our program is linked to dynamically at the runtime. And this sequence of PC values is known as the logical control flow or simply logical flow. Now consider a system that runs three processes as shown in figure this one. The simple process is illustrated over here, process A, process B and the process C. In this example, the execution of the three logical flows interleaved with the process are run for a while and followed by the B that runs to the completion. And whatever the processes we are using, whatever the process we are taking out, that the process C that runs for a while, followed by the A, which runs to the completion, and finally C is the assigned to the completion of, because why? Because the CPU time is CPU's time is more in the C, that is the process C. Whatever the C process, whatever the argument process, whatever the program running in this way, that appears to have exclusive use of the processor. Yes, that means CPU is very much used over here. Now comes to the logical flow, what is the process that is turned on. So that is used with the execution of the three logical flows, that is interleaved. Process A runs for a while, that is for a moment, followed by the B, which runs to the completion. Process 3 then runs for a while, followed by the A, which runs to the completion. Finally, C is able to run to the completion. So these are the various terms that is available for the run to the completion, that is take to run for the completion. And the key point in that processes that takes place turns using the processor, and each process executes a portion of its flow. Then it is used with the printed in the sense when multiple processes are in turn of taking the primitive process, and to perform or the program running in the program or whatever the program that is running in this one that is primitive, while other processes can take the chance. So that is available with the processes, that is available how CPU and how CPU executes. So that provide the CPU to periodically begin with the execution of the cycle with the execution of the measure that elapsed of the each instruction. That notice that the CPU appears to periodically stall between the execution of the some instruction in our program. However, each time the processor stalls, it subsequently resumes execution of our program without any chance or without any change to the content of the program's memory locations. And whatever the register we are taking out, whatever the data we are taking out with the program reference that is available with the program's memory location or the registers. Next is concurrent flow. Concurrent means at the same time. Yes, ek saath. Very good. The logical flows takes many different forms in computer system. Exception handlers, processes, signal handlers, threads, Java processes are all example of the logical flows, and the logical flows whose execution is also overlap in the time when another flow, that means is overlap in the time, overlap with the other processes, that is known as the concurrent flow, and the two flows are said to be or are said to run the concurrently. And more precisely, flows x and y are concurrent will respond to the each other if and only if x begins and after y begins and before y finishes. So it depends x, y, z or x, y. And for example, the processes A and B runs concurrently as do with the A and C. On the other hand, B and C do not run concurrently because the last instruction of the B executes before the first instruction of the C. And that phenomenon or that usage of the multiple flows executing concurrently is known as the concurrency. And the notion which takes place with these processes are known as the multitasking. That is also one of the portion of its flow known as the time slice. Therefore, or thereby, multitasking also refers to time slicing with the process flow that consists of the two time slices, we can say. Yes, that is independent of the number of the processors cores that is available with the computer that the flows are running out. Yes. So whatever the data we are taking out, that is referred as the multitasking, that is also referred as the time slicing. And for each flow, there is a time slice that refers to the consist of the two time slice. And notice that the ideas of the concurrent flows is independent of the number of the processor cores or the computers that the flows are running on. And if the two flows overlap in time, then they are concurrent even if they are running on the same processor. That is available with the processor that is used. Yes, that is running on the overlap. Yes. So that is used to identify a proper subset of the concurrent users, whatever the concurrent user we are using out. That is also known as the parallel flows. And if two flows are also running on a different processor cores to the computer, then we say that these are the parallel machines, so they are the parallel flows that is available on this one, and they are parallel execution. Yes. Now consider the three processes or the three processes with the following starting and the ending times. For each of the process, indicate whether they are running concurrently or not. This is a process pair, concurrent AB, AC, BC. Then private address space. So a process provides each program with the illusion that it has exclusive use of the system's address space. And on a machine with the n-bit address, the address space is the set of the two n possible addresses with the 0, 1 to n minus 1. And that address will provide each program with a private address space. Yes, that also provides a private address space. although the contents of the memory associated with each private address space is, if we can say in general, it is used with a 32-bit address or for 64-bit address. Yes. Then we are using the kernel modes. We are using the kernel virtual memory that is used with the user stack, that is used with the memory mapped region for the shared libraries, whatever the shared library we are using. Then runtime heap, read write segment, read only segment, that is available over here, that is loaded from the executable files, and that provides a mode bit, that provides a kernel mode, that provides a mode bit, it's said to be the 1. And whatever the process running in the kernel mode can execute any instruction to the or in the instruction set and access any memory location in the system. That is also provided with the privilege instructions, privilege mode, user mode. Anything we are doing in the input-output operation that is used to directly reference code or in the kernel address of the address space. Any such attempts results in the fatal protection fault, and user application or user program must interpret or instead uses the access control code and data indirectly via the system call reference or system call interface. Whatever the interface that we are using, that is used with the system call. And whatever the process running application code that is initially in the user mode, and only way for the process to change from the user to the kernel mode is via the exception or the interrupt fault or trapping the system calls. Whenever we are executing the instructions occurs, that passes the instruction to the instructor handler. And Linux also uses a clever mechanism known as the proc file systems. Next is context switch, that is used for the high level from the exceptional cases, that is used for the high level from the context cases. So whatever the scenario we are using for the kernel that is available, yes, that is available for the content that is used with the content of the various cycle, that is used with the page cycle, that is used with the page table, that is used with the file table. And that provides the execution of the cycle, execution of the process, and that is handled by the code in the kernel known as a scheduler. And whenever the kernel selects a new process to run, we say that the kernel that provides a kernel that is used with this one. That provides a context switch that switches the content of the current process, restore the saved content, that executes with the time, that executes with the process. Yes, that is executes with the various process also, that provides an interrupt with the cycle. Yeah, this is the diagram that shows how the process A is going to the process B, that is used with the kernel mode, user code, kernel code, user code, kernel code, user code. So one process, then process B, then process A. So this is going from process A to B and B to A. That the kernel is executing the instructions in the user mode on the behalf of the process A, and during the first part of the switch, the kernel is executing the instructions in the kernel mode on the behalf of the process A. Then system call handling, that is used with the error, that is used with the fork function also. Yes. Then PIDT, fork void, that is used with fork call. Then next is process control. How to control the process by way of the semaphores, by way of the lines, by way of the multiple choices that we are using from the system flows. Then creating and terminating the processes. This is running, stop, terminating. And the exit function, that is used with the exit status of the function. Then we are using the PID, that is the process ID, and there is a subtle example of this one, that is call once, return twice, then concurrent execution, whatever the concurrent execution we are taking out. Then int main PIDT, PID x equals to 1,